In this video lecture, we're going to discuss universal gates. If say universal gates, these are gates that can act as other gates. So it could act as and, or not. Okay. So the first universal gate that we're going to discuss is NAND gate. NAND gate is basically a combination of and not. So it means that NAND is equivalent to and negation, complement of and. So how does it work? If and output is based on 0, okay? So if there is 0 in your input in AND gate, the output is 0. While in NAND, if there is 0, the output is 1. Okay? And this is the symbol for AND gate. So it's the same as AND, but with a bubble. This bubble refers to the NOT gate. AND, NOT. And same as with AND gate, it accepts two inputs. So A, B, go to AND gate, and then go to NOT. So the final equation is NOT of AB. Okay? And the second universal gate that we're going to discuss is NOR gate. It is combination of OR, NOT gate. So it means that we negate OR to get NOR. Okay? If in OR, if there is an input of 1, the output is 1. But in NOR gate, if there is an input of 1, the output is 0. Okay? So this is the symbol for NOR gate, or with a bubble. And also, same as with OR, it has two inputs, A and B, input to OR. So we have A plus B, negated by NOT, we have NOT of A plus B. So this is the equation for our NOR gate. Okay? So now let's have an example how to implement other gates using NAND and NOR. So let's start with implementing NAND NOR as NOT. Let's start with NAND gate. So let's have this equation. Function is equal to X NOT. We all know that NOT operation, complement operation, only accept one input. But in NAND gate, it accepts two input. So how we're going to convert 1 to 2 input? By using theorem number 1. So still remember theorem number 1, x plus x is equal to x. X times x is still x. So using that theorem, we could transform single input to a 2 input. Okay? So instead of writing just x using theorem number 1, we could rewrite it as x and x. Okay? So under one negation, we have x and x. So this is and not. So therefore, we could implement NAND through this equation. So this will be our circuit. One source x going to the 2 input of NAND gate. So x, x, then and xx, not negation of xx, or basically x not. Okay? How about NOR? Same concept. So instead of writing x as one variable, we could rewrite it using 2 variables. Okay? So NOR is or not. So using theorem number 1, we're going to rewrite x as x plus x. Okay? So under one negation. So when we implement using NOR, this is the circuit. So x, one source, go to the 2 inputs of of NOR. So x here, x here. The result of this gate is x plus x. We have not, so negate the whole expression. So which is not of x plus x. We all know that x plus x is x. So basically it's just x not. Okay? So that's how we implement NAND NOR as NOT. Now, how could we implement NAND NOR as AND? Let's start with using NAND. We all know the difference between NAND and AND. NAND is the complement version of AND. Okay, so we need to introduce negation to AND operation. So how we're going to do that without affecting the value of AND? So let's have function equal to xy. So xy, we don't have negation, so we need to introduce negation without affecting our equation. So using theorem number 3, which is double negation, we could introduce negation to our equation. So we have xy not not. Okay, so we have and under not. So this is none. And we also have a not. And we all know that not could be implemented using none based on the previous slide. So using this equation, this will be our circuit. Okay, xy not, the first part of our circuit. And then xy not will be inputted to the second NAND. Okay, xy not, then we have xy not and then to xy not, and then we have negation. Okay, so negation of xy not, xy not. Okay, and we all know that xy not, and then to xy not is just xy not. Okay, how about NOR? So again, xy. So unfortunately, our main function here is AND. We need to transform it to OR not. Okay, so first we need to implement theorem 3 to introduce negation. So we have not of not xy, and we need to have OR to our equation. How we're going to do that? By analyzing or by implementing De Morgan's theorem on this negation, the inner negation. Okay, so when we implement the De Morgan's theorem in this part, so we have not of xy, it could be rewritten as not x plus not y, and the whole expression is negated. So we have or, and then we have not. So therefore, it could be implemented using NAND. And how about the x not, y not? Again, based on the previous slide, we could implement NOR gate to act as not. So kindly refer to the previous slide. So the result will be, for the first part of the equation will be x. Okay, so we have not of x plus x, y, not of y or y, and then these two will be inputted to another NOR. So it will be not of x plus x or to not of x, y plus y. And then the whole expression is negated. Okay, so that's how we implement and using NAND and NOR. How about OR? So using NAND, so again, using this function x plus y, so we need to transform this OR to be AND. So we could do that by implementing De Morgan's law, but unfortunately, we don't have negation here. So it means we need to implement theorem 3 first to introduce negation. So we have not of not x plus y. And based on the previous slide, I'm going to analyze or apply De Morgan's law on this negation. Okay, so it will be rewritten as, okay, x not, y not, and then the whole expression is negated. So now the main function is and then it is negated. And again, x not, y not, kindly refer to the previous slide, how to implement negation using NAND gate. Okay, so this will be our final equation that we're going to use to implement NAND as OR. So this will be our circuit. And how about NOR? So basically, we're just going to introduce negation to our OR to act as NOR. So function is equal to x plus y. Using theorem number 3, we have double negation. So not of x plus y is nor, and negate it again. So it could be implemented using nor. So refer to the previous slide. So this will be our circuit. Okay, so that's how we implement non-nor that will act as other gate. So that's why when other doing circuit design, they choose NAND or NOR in their circuit so that they are just dealing with one gate. Okay, so most of our IC are implemented using NAND gate, okay, or NOR gate. Okay, so that's it for this video lecture. See you on the next video lecture. Thank you for listening.